Imagine a radiant item dissimilar to anything we've at any point owned, hopping the tremendous field of room at multiple times the speed of the ordinary comet in our planetary gathering. This isn't a manufacturer of science fiction, however, a weird visitor entering our planetary gathering in 2017. This novel item is the first interstellar item at any point saw, as in our close-by planet bunch, named Oumuamua, in Hawaiian significance, a courier from a showing up first. It has confused stargazers and delivered theories, going from it being basically a space rock to maybe an outsider space device cruising through our galactic neighborhood. Oumuamua was 15 million miles from Earth, on numerous occasions the distance from Earth to the Moon. What astounded researchers was its speed. As it pivoted around the Sun, its rate expanded, going against the laws of heavenly mechanics. Might it be actuated by some unexplored world type of infinite radiation, or is it a comet producing gases in a way we've never saw before in a universe represented by guidelines and conditions? Oumuamua is a confusing condition, a huge puzzler looking like a stone around 650 feet long. On October 19, 2017, a telescope in Hawaii got a powerless streak. This was no normal heavenly body, it was Oumuamua, the first known interstellar object to visit our close-by planet bunch, dissimilar to space rocks and comets brought into the world under the gravity of our Sun. Oumuamua was a drifter from somewhere down in interstellar space. Its direction showed that it was not limited by the Sun's gravity, making it a transient guest to our framework. What sets Oumuamua separated isn't simply its starting point, however, its novel characteristics, its stretched Stoga shape, its fast revolution, they don't fit the norms of normal objects in the close-by planet bunch. The scholarly local area is humming with speculations and conversations about the nature of Oumuamua. Is it a comet without a tail, as seen with its strange revolution, or something completely different? These inquiries have ignited exhaustive logical examination, prompting an exhibit of theories, from it being a part of a bigger divine body to considerably more theoretical thoughts, for example, it being an outsider test. The disclosure of Oumuamua is a breakthrough in cosmology, much the same as when individuals originally glanced through a telescope and understood that Earth isn't the middle of the universe. It reveals insight into the arrangement of the close-by planet bunch and advises us that our close-by planet bunch is just a little piece of a gigantic, neglected wilderness. As Oumuamua moves farther away, turning into a weak spot in the immense ocean, the craving to concentrate on it develops. Ideally, with further developed telescopes, we will catch more data about these interstellar couriers, offering new signs about the construction and history of the universe. Further examination of Oumuamua uncovers interesting subtleties. At first named a comet, it had none of the ordinary comet-like highlights, for example, a splendid unconsciousness or tail. It was for this reason that it was renamed as a space rock. However, it isn't simply any space rock, it is an extended Stoga-formed object dissimilar to any space rock we've seen before. Its one-of-a-kind shape has prompted different hypotheses, including the probability that it's an outsider space contraption. Logical papers portray the actual qualities of Oumuamua in more detail. They notice the object is tumbling instead of turning, which is surprising for both space rocks and comets. This tumbling movement could be the consequence of a crash with another planet. However, this state is only theoretical at this point. The direction of Oumuamua presents another riddle. It entered our planetary group at a curiously high speed and continued in an exaggerated direction, which thus implies it will never return. Most objects captured by a star's gravity go into a curved circle, however, not Oumuamua. According to researchers, doubts its direction was influenced by non-gravitational forces, which can be surmised by the arrival of materials because of quick vaporization. However, no such gas discharges were obviously saw, which further adds to the secret. The absence of a noticeable unconsciousness in the object's high velocity has prompted different theories. Each detail uncovered about Oumuamua adds to the puzzle, inciting further examination and hypothesis inside the scholarly local area. A few researchers propose it could be a piece of a bigger object that fell to pieces. Others accept it could be another class of object rather than a comet or a space rock. Some even engage the likelihood that Oumuamua is a sun-powered sail driven by radiation pressure. The fact that the object's fast could make it a core from another star framework, may be shot out by a planetary framework circling a youthful star. This could make Oumuamua one of the first noticed interstellar objects, a remainder from one more piece of the universe. The story of Oumuamua is a space criminal investigator story where each piece of information just develops the secret. Its extended shape is not at all like anything we viewed as in the planetary gathering. Might this remarkable shape sometime offer benefits for interstellar travel, such as diminishing drag or expanding soundness, or on the other hand, is it the consequence of some calamitous occasion that we can't yet grasp? Its direction adds one more layer to the secret. The shortfall of a noticeable tail precludes the likelihood that outgassing affected its way. So what non-gravitational powers are working here? Might it at some point be affected by dim matter or another obscure infinite inconsistency? The speculations encompassing Oumuamua range from the conceivable to the phenomenal. Might Oumuamua sometime be a harbinger, a core from another star framework? The probability that it's a sun-powered sail is especially fascinating, and whenever demonstrated, it would reform how we may consider space travel, opening up the chance of radiation-propelled ventures between stars and investigating divine articles like Oumuamua. Stargazers depend on different apparatuses. The examination into the idea of Oumuamua was driven by a group of specialists that included Jennifer Bergner, a physicist at the College of California, Berkeley. Bergner and her associate Darl Seligman, a space expert at Cornell College, were at the front of unwinding the articles confidential. Their work, distributed in the diary Nature, is viewed as the most persuading model of Oumuamua's starting point, as indicated by Marco Melli, a cosmologist at the European Space Organization. The group's perceptions were upheld by NASA's Hubble and Spitzer telescopes, which found that Oumuamua had a strangely prolonged stoa-like shape and marginally accelerated as it left the planetary gathering. This speed increase is in many cases seen in comets when they're repulsed by the material they transmit. However, Oumuamua showed no such outflow or any noticeable unconsciousness of residue and gas, which we would expect of a comet. The group utilized demonstrating to exhibit that Oumuamua could have started as a run-of-the-mill water comet circling a nearby star prior to being catapulted out of the framework. High-energy inestimable beams could have changed over up to 30% of the comet's water ice into hydrogen, which might have been caught in Oumuamua's ice as it went through interstellar space. As it drew nearer to the Sun, the caught hydrogen ought to have been delivered, giving the article the speed increase seen by Seligman. The group's hypothesis accounts for each strange part of Oumuamua. It recommends that Oumuamua was for sure a comet, though a surprising one. The shortfall of a noticeable unconsciousness or tail can be made sense of by the way that nuclear hydrogen is a lot less massive than the materials trans by ordinary comets, and along these lines doesn't entrain a lot of residue. While Bergner and Seligman's hypothesis is persuading, it's vital to take note of that not every person in the logical community is persuaded. Karen Meach, a stargazer at the College of Hawaii at Manoa, still trusts that the customary model of a comet might have happened. She proposes that Oumuamua could just have a little measure of residue, which would likewise make sense of the shortfall of a noticeable unconsciousness or tail. Another hypothesis that Oumuamua could be an outsider test has caught the public's creative mind. Its prolonged stoa-like shape and strange direction have prompted the hypothesis that it could be an artificial article. This hypothesis acquired some footing when Avi Loeb, an astrophysicist at Harvard, recommended that Oumuamua could be a meager, level, almost rectangular piece of material that could be a test dispatched by a high-level development. Loeb's hypothesis was generally detailed in the media, powering hypothesis. Anyway, while the outsider test hypothesis stood out as truly newsworthy, it has not endured logical examination. First, if Oumuamua was a test, it would likely have discharged some type of radiation or signals that would have been recognized. Furthermore, its tumbling movement isn't steady with what one would anticipate from a test intended to consistently move or gather information. Besides, the article's direction can be made sense of by natural irregularities, as examined in the past area. The hypothesis proposed by Jennifer Bergner and Darl Seligman, which recommends that Oumuamua is a hydrogen-rich comet, represents its interesting attributes and doesn't need extraterrestrial mediation. The thought that Oumuamua could be an outsider test mirrors our aggregate interest with the obscure and the chance of clever life past Earth. However, it likewise fills in as a useful example about the significance of theological research. Theoretical theory, while fascinating, can redirect consideration away from a more plausible clarification. Although Oumuamua's novel characteristics have confounded cosmologists, the most probable clarification is that it is an uncommon sort of comet or space rock. Its long venture through interstellar space likely modified its synthesis, forming an outside that held a large portion of the frozen gas inside. This theory represents the exceptional attributes and is upheld by perceptions from NASA's Spitzer Space Telescope. The disclosure of Oumuamua has huge suggestions for how we might interpret interstellar articles. It recommends that trillions of such articles might pass through our close-by planet bunch, and we've just barely started to recognize them. The enormous Brief Overview Telescope in Chile is set to accept its most memorable engineering camera light in December 2023, with full review activities booked to start in October 2024. Once functional, LSST will possibly have the option to identify more objects like Oumuamua. It is projected that LSST information will be completely openly accessible in 2 years, opening up new roads for understanding these strange interstellar guests. Past telescopes, advances in impetus innovation and information investigation might permit us to catch and concentrate on these articles all the more intently. Envision a future where we could send a test to rendezvous with an interstellar article, gather tests, and send back information progressively. The advancement of the European Comet Interceptor mission was as of late subsidized. The mission addresses a huge jump in our capacity to concentrate on interstellar articles like Oumuamua. Similarly to past missions that were intended to concentrate on objects inside our planetary gathering, the Comet Interceptor is explicitly intended to gather information on objects from outside it. The mission is driven by ESA, with help from the Japanese space organization, JAXA. The project expects to concentrate on a comet that has spent little energy in the intersolar-oriented framework and might be visiting it for the first time. The mission will expand on the triumphs of Rosetta and past ESA missions that visited brief-period comets. The shuttle will comprise of a primary unit and 2 tests intended to observe the comet from various points and make a 3-layered profile of its yet-to-be-found item. The mission is reputed to be sent off in 2029 and will venture out to space with ESA's airborne mission. Once in space, the Comet Interceptor will hang tight for a reasonable object at the L2 Lagrange point, an area 1.5 million kilometers behind Earth when seen from the Sun, hanging tight for the following interstellar item to go through our close-by planet bunch. Once such an item is distinguished, the shuttle will change its direction to make a nearby flyby, catching high-resolution pictures and gathering information on its structure and beginning. The revelation of Oumuamua has opened a new section in cosmology. How normal are such hydrogen-rich articles in the universe? Might there be other interstellar objects with various pieces and ways of behaving? And above all, how might we get ready to more readily concentrate on these articles in the future? Oumuamua has filled in as a harbinger of future disclosures, empowering us to plan for new interstellar guests that might be similarly or even more confounding, while maybe not all the more so.